All right, let's talk about the problems in 7D. First, number 2 was a question, and it said, give an example of a rate used to measure risk in travel. So I just kind of looked at the table further down on that same page, and it said traffic fatalities 41,817 for miles driven. So a rate would be number of fatalities per mile driven. And so you could just do 41.817, comma 817 over 2, comma 400, comma 000, comma 000 to go 10 to the 9th. Move it 1, 2, 3, 1, 2, 3, 4, 5, 6, 79. And that's so many per mile. And if you divide that out, you get point something. And the reason they're good is because here it looks like the number of fatalities increased between 1995 and 2000, but the miles driven increased by a larger percentage. And so if you do the rate, you'll actually find, if you take this divided by that, you'll find that the rate of fatalities is going down even though there is more fatalities. And so the rate gives you, in some sort of sense, a better idea of how things are going. Okay, so that's the point of doing rates, and I think that and the rate is also similar to probability, because you divide them and you get the chances of being a fatality per mile if you just divide these two. Okay. Now, number 10 says, express the 2010 fatality rate in deaths per thousand. So in 2010, there was 32,885 fatalities, and it said per 100,000 people. Well, the population was 309 million. So to get the rate, we do 32,885 divided by 309 million. And that would be deaths or fatalities per person. But if we wanted deaths per 100,000 people, we'd take it times 100,000, and we get the deaths per 100,000 people, because this tells us how much per person times the number of people tells you how many fatalities there are in the 100,000. So that would be the deaths per 100,000. And I'm not working these out on the calculator. I assume you can do that. Next one is 11, and that one says express the 2000 death fatality per 100,000 licensed drivers. So you would do the same 32885 divided by 309 million. Nope. Licensed drivers, not 309 million licensed drivers. The licensed drivers is 210 million. 210, comma 000, comma 000 per 100,000 times 100,000. And that would get you 11. 12, same kind of problem. Use 3 different fatality rates, deaths per 100,000 people. That was this answer. Deaths per 100,000 drivers, that would be this answer. And deaths per 100 million vehicle miles, to compare the risk of automobile travel in 1995 and 2010. So they want you to do all 3 of those for 1995 and 2010 and see if things are getting better or worse. And I haven't done those, but that's all you have to do is figure out this number and this number, and the other one for here for trillions of miles. and that's 2010. Then go back and do all of those for 1995, and see if the rates are getting better or worse. Okay? So that would be 12. All right. Now let's go on to next one is 14. And 14, we're supposed to compute the fatality rate for 100,000 flight hours in 2006 and 2010. By this measure, has general aviation become safer? Fatality rate for 100,000 miles flown in 2006, 706 per hours flown, 24 million per 100,000 times 100,000. And then we're supposed to compare that to 2010, which is 453 per hours flown, 20 billion, 200,000 times 100,000. This number decreased, so did the total miles, total hours. Planes must be faster. And so the first one, I'll actually do this calculation for you. So I'd go 706 times 100,000 divided by 24 million, and I get 2.94. 2.94 deaths per 100,000 hours flown. And then let's do the other one. 453, and now for not 24 but 202, and that's 2.24. So looks like flying based on this measure is safer. That many fatalities per 100,000 hours of flight. So there, if there was, everybody flew for 1 hour, there'd be almost 3 deaths out of every 100, almost 3 people die if everybody flew 100,000 miles. And then this is down to almost 2, almost down to 2, 2 1/4. Okay, that's 14. I'll stop that video and start a new one.